Hello, we are going to discuss here a typical circuit which is useful for avoiding contact pitting in contactors. You see, what is contact pitting? Contact pitting is in our AC supply. When we switch on a particular load, we are not sure as to what time period are we switching, at what time situation we are switching. We could be switching it at here, or at the peak of the supply voltage, or at the peak of the positive or the peak of the negative, doesn't matter. But then if it is at the peak of the voltage, then the current will be highest. And because of that, the spark takes place, and because of that spark, the contact pitting takes place. So what we have given novel idea here as to how to avoid contact pitting. This is the basic concept. So let's look into this basic concept, and let me zoom it to an extent so that we will be understanding it better. The basic concept is that we have a supply, we have a load, then we have a triac, and then this triac is triggered through the main supply at the time of switch on, and that is how the load is switched on. But after some time, as decided by the circuit parameters, this switch closes. So in the process, what happens? The triac is bypassed, and then now the current flows through the contacts. Because initially we are not trying to allow the current to flow through the contacts, as we discussed, because there will be a peak current, and peak current means there will be a spark. But here, because we are switching on at the zero voltage, we will see that circuit as to how do we switch it on at the zero voltage, and then once the switching on takes place, after that we switch on the relay contact. That is the basic concept. Now let's go back to the concept, circuit concept. Here we have very standard things, that we have a transformer, this small signal transformer, and there's a bridge rectifier, and then we have some 7805 for 5 volt. And before the filtering takes place, we have tapped the voltage, and then we are giving it to a transistor which will be developing zero voltage pulses. We are taking the pulsating DC and not the filtered DC. We are taking the pulsating DC and then feeding to this transistor to get zero voltage pulses. And that is how these zero voltage pulses will be fed as a clock input to a decade counter, and this decade counter will go on counting till the setting is met, and it will reset the counter. And that is how then the relay starts operating. We will see its function once we start operating this. We will be able to understand it much better. Now let us start with a particular frequency. Let's say, now let me start with a 50 Hz frequency, and 312 volt is the peak voltage, and the RMS of course will be different as far as the calculation is concerned. And then when we switch on this, what we notice, you see, this is very fast. It has switched on from here to here, and then the relay has switched on to this side and making the contact in parallel. Now if you look at this waveform which we have discussed, that we get pulsating DC, and then these are the zero voltage pulses. That is what, because we need the zero voltage pulses for understanding or for switching or not at the zero voltage. Now we will now match it very clearly. Now let's change the frequency to about say 1 Hz. Now what I do is, when I switch on this, what we notice, let's not look at this because this is no more, this is the basic concept which we are trying to explain. And here what we have done is, we have the contactor here or the relay here which can be drive to a contactor, and the same thing what circuit we have shown here, the same circuit, and then we have used a zero voltage optocoupler. This is directly connected to 5 volts. No, it should not be, because in the simulation it requires to be connected to 5 volts, otherwise it should go through a resistor. So what happens, and the optocoupler is the zero voltage optocoupler, MOC 3061, MOC 3063, these are all zero voltage optocouplers. So what happens when we switch on, as we see, what we had seen here, when we switch on, it triggers through the optoisolator, and then the triac conducts. Once the triac conducts, after some time the relay will switch over to this side. This since we cannot see at a very high frequency, that means at 50 Hz we can't see, we will now operate at a low frequency, and we'll see how the counter goes on counting from here to here. So we have provided some LEDs in order to see how it is working. We will first watch this, that this lamp will come immediately at the time of switch on, and after some time this relay will change over. Now please look at it carefully. So when we switch on this, you see this lamp has already started glowing. and after some time the relay changes. Come again, we will see what is happening. Just watch this. The load will be glowing. The lamp is the load. Load will be glowing. Load will be on, and immediately we switch on. But after some time, based on this setting that we have done here, the relay switches on. So that is how contact pitting is avoided. Now let's watch it. Now see, the lamp is on. Relay contact has not taken over. Now the relay contact has taken over after the counting is over. We have deliberately done it at a lower frequency so as to see this clearly. Now if we change it to 50 Hertz, we will not be able, because it will be doing so fast, we will not be able to do it. Now we have taken it at 2 Hertz. Now switching over to 50 Hertz, we switch it over to 50 Hertz. We will not be able to see it because it will happen very fast. Now let's see this. It's very fast. And that is how the contact pitting can be avoided for contactors which are generally used in electrical circuits. Thank you. Please subscribe.